Okay guys, so question 1 was, what is HTML? Well, HTML is hypertext, that's just one word, hypertext markup language. Okay, that's what it stands for. So where is it used? This is a pretty cool website. It's about chocolate. It's called chocolate.com. This is HTML. HTML is the code used for the structure of a website, and it uses tags. So if I go back to the question, it is used for the structure of a web page. Well, I'm going to change it to is used to create the structure of a web page using tags. And that is HTML, hypertext markup language. We then got HTTP. HTTP is this. It's a protocol, it's a language, it's a rule. So it stands for Hypertext Transfer Protocol. And what does it allow? It allows a device to communicate with a website through a browser. So basically it allows your laptop, your phone, let me just add this on. It is rules to allow your phone, your smart TV to basically get a web page and then display it. It displays it using HTML, which is what we looked at a second ago. But Hypertext Transfer Protocol is simply rules which allow a device to communicate with a website through a browser. HTTPS stands for, where's my mouse? Hypertext Transfer Protocol. Secure. It does the same as HTTP. It is rules to allow, but the difference is secure communication between a device and a website. Now, a lot of you, basically for this, just said that HTTP is a protocol. HTTPS is a protocol secure. Not good enough. You need to say the name, and even better, to say what it is. This is secure communication between a device like a phone and a website. Their rules. HTTP, rules again, to allow a device and a website to communicate with each other. The next question. Explain the function of a web browser. So, we're in Google Chrome right now. The job of Google Chrome is to, let me just move this up. The job of Google Chrome, which is a browser, is to translate HTML, which is this, the code of a website, into the website we were expecting. So Google Chrome is an app, it's a program, it's software. So a web browser is software. The job of it is to translate HTML code into the website we were expecting. A web browser is software that converts or translates, let's see, translate HTML into the web page that we were expecting. So a lot of you said this, but you didn't say this. but it's software. Okay, so guys, this is in your booklet. This is a URL. I asked you in your booklets to also identify this. Well, easy tiger, Mr. Levin, you naughty person. There we go. Which is a server name. Server. And then N for name. And anything after this slash is called a file path or file name. So if we look at the question, HTTP is always going to be the protocol, always. So HTTP, oops, easy, with a dot slash slash. In future, if you haven't got dot slash slash, I give you the mark. Next time, I won't. The file name is anything after the slash, so it's this. Computer science papers. That's called a file name. Computer science papers. And the web server name is a server name, which is everything from the www to the .ca, or in this case, .uk. www.cia.org.uk. That is that. Pretty easy. Okay guys, so for this question, I'm just going to quickly do my units. So, very quickly, BY for bytes, KM, megabytes, gigabytes. So we don't need any higher. What we're turning is from megabytes into gigabytes. So you should know by now that's dividing by 1,000. 1 minute of video is 180 megabytes. So 180 megabytes is 1 minute. We need to work out 2 hours. Well, how many minutes are there in 1 hour? 60. How many minutes are there in 2 hours? 120. So we've got to do some math. 120 multiplied by 180. And we call this long multiplication. I'm not going to do this for you. Your challenge is to finish this off if you got this wrong. You're going to get an answer. Whatever that answer is, you then need to turn it from megabytes, which is what the answer is going to be, into gigabytes. If you don't know how to do long multiplication, you need to go on YouTube and have a look and type in doing long multiplication. Simple. I will be testing you on this. Alright guys, so basically this is a pretty easy question. We know that red, we know that red is 0. So I'm going to do here, red equals 0. We know that green is 1, because it says it here, green is 1. So G equals 1. Now remember the rule, every time there's a 0, you need a line with a NOT gate. Every time there's a 1, you just draw a straight line. So light A is red, so I'm just going to put a number instead above it. So red is 0, so I'm going to do A is 0. So I'm going to find A, and I'm going to do a NOT gate, because A is 0. I'm then going to do B, C, and they're both green. So I'm going to do B and C, and they're both green, so just straight lines. Now B and C are connected together through an AND gate, because it says it there, B and C. So I'm going to do an AND gate here. So now I've done this, I'm going to cross it out. I've also done this, so I'm going to cross it out. So we're left with this AND here. So we need to connect this knot to this AND gate with another AND gate, because it says it there. Boom. So we've now done this. I'm now going to get a different colour to make it easier. I'm now going to skip this OR, and I'm going to go straight onto the light A is green. So I'm using this line again. So the rule is, if we're using a line again, we need to do a big dot. And as it's green, I just go to a straight line. I'm now going to do B, which is red. So B, I'm using it again, so I'm going to do this. And it's red, so it needs a NOT gate. C is red also, because B and C are red. So C, I'm going to do another line coming out of C, and that's also a NOT gate. So I can cross this out, because we've now done B and C. We've also done A is green, remember? This line here. So now what I want to do, oh, there's one thing I need to do. Oopsie daisy. So I've done, that is red, and that is red. So light B, C is red, but I haven't joined them together, so I need to join these together by this AND. So we've got light A is green, which is this line here, hello, which we need to connect to this gate here by this AND. And we've now got another AND gate. The final thing we want to do is link this gate with this gate, and we do that by using the OR here. So I'm going to draw a line from here, a line from here, and an OR gate. And there we go. Easy peasy, lemon squeezy. You saw my method, you do it step by step. Recap, watch it again, see how I got this data over here first. Then I did each little bit. So I did light A is red, I then did B is green, C is green, and then linked C and B together, and then I linked them to A, and I did the same down below, bit by bit. We then get the truth table. So I'm not going to do the whole thing, I'm just going to do a little bit, and you guys, if you got this wrong, should finish it off. So if A is 0, and B is 0, and C is 0, what happens? So let's trace it through. In fact, let's do these zeros outside it. So 0, 0, 0. Well, to begin with, if A goes through here, it's going to be a 1 here. Also, A, being a 0, will travel this line, and it'll be a 0 here. B is a 0, so I'm going to do this black line, I'm going to put it here. But also B will follow this line, we'll go for this knot, which will turn it to a 1. C is a 0, which will follow this red line, it'll go through the knot, which will be a 1. And it'll also C will follow this black line to become here. So 1 and 0 is 0, so it's going to be here. 1 and 0 is also 0, so 0 is going to be here. 1 and 1 is 1. 1 and 0 is 0. So 0 or 0 is 0. So that is 0 there. So let's undo everything. So the next one is 0, 0, 1. So if 0 goes through as A, if it's not, we know that's going to be a 1. If 0 follows this red line, we know it's going to be a 0 here. If B goes here, it's going to be a 0. If B follows this red, it'll go through this NOT gate and it'll be a 1. This 1 will travel the red cable to this NOT, which will turn it to a 0. The 1 will also travel up here to be a 1 there. So we've got 1 and 0, which is 0. We've got down here 1 and 0, which is 0. This 1 and 0, which is 0, should be here. 0 and 0 on this AND gate will also be 0. 0 and 0 will be 0. I want you, if you got this wrong, to finish off the rest. Okay guys, so we did this last year, serial and parallel data transmission. Parallel, most of you got this right. So we know that it's data which travels down multiple channels, 8 channels normally. 8 bits, 8 channels. So 1, 2, 3, 4, 5, 6, 7, 8. And on here you have bits of data. So 1 bit of data, 2, 3, etc. All traveling at the same time. So data traveling down several, so 8 channels at the same time. Whilst serial, we know it's data which travels down 1 channel, 1 at a time. Serial, data traveling down 1 channel, 1 bit at a time. Most of you got this right. Some of you got this the wrong. In fact, one of you got this the wrong way round. Some of you didn't mention the amount of channels, like 1 channel or several 8 channels. Some of you didn't mention that it was data that was traveling. Okay, some of you really overcomplicated this question. The question says, give one benefit of each type. Some of you didn't write enough. So some of you just put, it is faster. You're right, but faster for what? Faster in running? Faster in eating? What do you mean by faster? That isn't enough. So you need to explain it. It is faster to transmit, because that's what it's doing, data transmission, data. Now if you put Y, even better, because data travels down multiple channels at once. But a key bit, excuse me, is this bit. Especially this bit, which most of you missed. For serial, it is more accurate when it is transmitting data due to it arriving in order. So remember, it travels 1 by 1 down 1 cable in order, so it's more accurate when it's sending data. Most of you just put what's in black. That's not good enough. You need to mention when transmitting data. Even better if you also put if you also put because it arrives in order. I appreciate last year we did this, but this is testing your memory. So primary memory, there's only two different types of primary memory. That is RAM and ROM. Secondary storage, we looked at two main types, solid state drives or SSD and hard disk drives, HDD, not soft disk drives, which somebody put. So these are inside your computer. So primary is memory. Okay, so primary is to do with memory. RAM, which is random access memory, and ROM, read-only memory. So you've got to remember RAM and ROM is to do with primary memory. So if you see this in the exam, you straight away write the word memory to help you out. Secondary is inside the computer normally. Offline, you've got a wide range of different offlines, such as DVDs, such as CDs, such as Blu-ray, such as USB memory sticks. These are external to the computer and they allow you to use them at multiple devices. External hard drives. So folks, your job is to explain what you're going to do next to sort out your weaknesses.